Yeah. Okay. Hello, everyone. My name is Mlynár. I'm a client architect at Stratox, and usually I'm helping our clients to improve their software delivery processes, improve their way how they are using the software delivery tools. And of course, we as Stratox, we are really focused on microservice development and cloud-native development. So I think that that's a pretty good match with the topic for today. I will. There is, of course, a lot of tools in this area. I will try to go and provide you some overview of them. If you will have any particular question or interests, we can stop at any time and discuss some more details if you like. So, what are the key components for the microservice or cloud-native development? What will you need to develop any application which is supposed to work in cloud or be ready for the cloud, and of course to have some proper microservice structure. I know that you have already had some lectures about microservices, about patterns, so I hope you are a bit familiar. I don't know how many of you have already practiced or did programmed something with microservices, but let's assume you have some experience. So first thing what you will need for sure is some programming language to develop the piece of code. Usually today the frameworks are pretty heavily used to shorten the time for the development and make it more efficient. The next things are not so obvious already. The most important part for microservices are containers and orchestration of the containers. Do you know why it is important? Why the containers are so important for cloud native and microservices? Okay. If you have microservice architecture, then you are usually developing some small pieces of the code, small components, and as an opposite to monolith architecture, you end up with not only like 2-3 components which are making your work for the whole application, but you easily end up with 15, even 50 components at the end. And without the help of containerization, it would be really not even pain, but impossible to run such a solution on a production grade for some real production purposes, delivering some kind of value to your client. So containers are really important. Then service mesh and API gateway are next topics. We will go through and deep dive a bit into details regarding this. Message brokers. I hope that at least you know what the message broker means and why they are important. Do you remember something from the previous lectures about this, or do you have any experience with the message broker? Who do have an experience with the message broker? Who used Kafka or RabbitMQ or anything like that in practice? No one. Okay, we will go there. And if you have the solution up and running, then for sure it will be very important for you the monitoring logging, and tracing. We call it observability stack, which is the part which will allow you or make it easier to run and operate your application, make it working all the time, which is usually the goal. And then there are two specific topics, debugging, which is a bit different than debugging in a standard monolithical application, and we will talk also about the CI/CD pipelines and some configuration management. Okay, so which options do we have regarding the programming languages? Yeah, I will provide you some brief overview. Of course, the list of languages I will mention is not complete. You can use many other options if you like, but I will try to provide you some really most used languages. Java is the #1 in microservice world. Why? Because it's really quite mature language already. There are a lot of libraries available. There is a very, very strong community to support you as a developer. Even if you don't know anything how to do it, you have any issues, then there is always a lot of options how to ask the community about that. And of course, there are some advantages coming from the way how the Java is designed. It has a static typing and just-in-time compiler functionalities. What is the problems? What are the problems coming with Java? Well, the syntax is sometimes not so easy to manage, and of course usually Java applications or Java components are a bit heavier than the other languages are offering, and of course with microservices coming to the daily practice, there are new frameworks which are coming and making the Java usage more efficient. So what are the frameworks you can use? There are a couple of them mentioned here. Most probably you can get Spring Boot or Micronaut. The others are not so often used, especially for microservices. If you choose any of them, you will not do any mistake with that. And it's expected that Java will remain as a really main language for the microservices and cloud native development, especially if we are talking about Europe. Because in the US, the situation is a bit different. The major language in United States, in North America, to develop any application, but also microservices, is C# or any .NET programming language, but C# in particular. The advantages are more or less the same. C# and Java have very similar curriculum. The difference is that Java is community supported, community recognized, and C# is heavily supported by the Microsoft. But also the community is really strong about it, and we can say that it's a bit less popular than Java, but this is more like European perspective. So with C#, it's also very good way to go for the microservices, and either Java or C#. If you will focus on those two languages, I think you will not have any trouble to get a new job as a programmer. There is one specialty with the C# and .NET. Usually it was perceived and really like focused on the Windows world. So in the past, if you developed something in C# or .NET framework, you were really you had to run your application on Windows-based systems. This is not true anymore since .NET Core 6. Nowadays we have .NET 7 and .NET 8 will come in a couple of months. It's not true anymore, so you can run these components developed in C# in Linux-based virtual machines, Docker containers, whatever. So there is no this kind of limitation anymore. Another very popular language today is Python. It's not so, let's say, microservice focused language, but it's becoming very popular, especially in AI community. And there are a lot of advantages, a lot of libraries available, especially in AI world, and that's the reason why they are using it. One can say that Python is much less efficient, much more resource demanding than Java or C#. That's true, but I would not expect that, or it's not usually the case that Python is used for everything. Python is used like for the microservices, which are kind of orchestrating the library or using the libraries or other microservices which are written, which are coded in more efficient languages. Even C, C++ are used in this context. There are some other issues with the multi-threading capabilities, but in the context of microservices, this is not such a huge problem, because you should use message broker as an asynchronous break, and in that case there is no issue or not so much concerns about the multi-threading. Other languages, you can use Go or Golang. You can use Node.js. This is quite popular for the developers who are familiar with the front-end development. So it's possible to use Node.js to develop microservices as well. I would say it's not the best way, but it's still some reasonable tool to be considered, especially if you will take Koa as a framework for really intended and focused for the microservices. So some comparison of the languages from the performance point of view. Go, Java, and C# are more or less on the same level. Node.js is slower, and Python is the slowest language from the performance perspective. While from the ease of use, how fast you can start to use it, Python is definitely the best one. So if you would like to develop something to learn something, then start with the Python. You will have no problems. If you have to develop some really real-time critical and application where you expect that you have to manage a lot of load, then go for C#, Java, or Go. Also, it's possible to use approach where you will develop the first version of the component in Python, for example, to see if that makes sense, if such component is bringing the value, and if yes, and you will need the optimization of the component, you can refactor the component in more efficient language. Yeah? So it's better to go with a Python, spend quite a small amount of time to develop something. If it's the right way, then switch to Java or C#, and you can be more efficient, and you will spend the time on the code in a more efficient way, because usually you will get better requirements, better understanding of what the component should do than at the very beginning. Popularity, yeah. It's not very common, but it depends. If it's some bigger enterprise, then they have really teams which are focused, specialized to develop some prototypes, some MVPs. Once the MVP is delivered and the business will confirm, yes, it brings the value we expected, maybe there are some adjustments of the requirements and so on, and then the whole package is handed to the some core team or the teams which are then maintaining the development of the application on a continuous basis. And then they are refactoring the microservices, the application. Usually they don't do like refactoring of all the components at once. They will start with the components which are like most consuming from the resources perspective, and that's it. Okay, so I think all mentioned languages are in quite strong position. There is none mentioned which is expected to really come out from the mainstream. So it depends which language is more familiar to you. Then it's better to use it than to really like heavily use something you don't know. On the other hand, the huge advantage of microservices and the components is that you can use for every component different stack, different programming language. So if it's something important, use other language than when you need some kind of flexibility. Okay, containers. There is a huge shift in the past like 5 years from the virtual machines to containers. Why? Because when you had the monolithical application, then there were no issue with having one virtual machine for some middle tier, for some backend component, one virtual machine for the database, one virtual machine for the front ends. If you have like 20, 30 components, then it doesn't make sense so much to configure virtual machine for each component. Okay, then you will come to the conclusion, let's deploy more components into one machine. The problem is that the components could interfere with each other. I don't know, one component needs some library in the version A, another component needs the same library with a different version. Maybe they have some other dependencies, and then you will have a lot of conflicts to resolve. So the way how we solve this issue is we will encapsulate each microservice, each component to its own Docker container, having all the dependencies, all the libraries enclosed in the Docker container, and then you can deploy virtually as many containers to one node as you can. So Docker is really, really helpful from this point of view. Then you will realize, okay, I have 30 containers I have to manage. But at the end, you don't have only one environment. In professional software delivery, you have usually some development environment intended just for the developers as a sandbox for continuous integration. Then you have at least one testing environment, and you have at least one production environment. Those are 3 times 30, it's already 90 containers to be managed. It's quite a lot more than you would like to manage as someone to trying to keep everything up and running. And this is where the Kubernetes is coming to the game. Kubernetes or Docker Swarm, but we can say that Kubernetes is taking over the initiative nowadays, is the platform, is the solution for orchestration of the containers. So if you utilize Kubernetes, you don't have to worry about which Docker containers are running where, if they are running or not, because this is everything managed by the Kubernetes. Kubernetes as itself, I think it's a topic for the whole semester, if you like. But if we are talking or looking at the Kubernetes from the developer's perspective, then you can hide a lot of complexity which is inside, and usually the developers are using some abstraction, some tools which are running on top of Kubernetes and providing the abstraction of the complexity which is behind. As a developer, you don't have to know a lot of things, how to configure this and that, and that's on. So containers. When you have the containers in the Kubernetes cluster, you can deploy them, of course, directly to the Kubernetes. Then you will solve the issue how the containers are communicating between each other. Is it possible to communicate? Is it allowed that container A is communicating with the container B? Okay, that's one of the issues you have to solve. Then maybe you will have some higher load, a lot of requests coming. Then maybe you will need to have more instances of the same container to be running to manage all the load. Maybe you have to encipher the communication between the components, between the containers. And in that case, you have 2 options. Either you as a developer should solve it, or you can use service mesh. Do you know what the service mesh is? I think you had already some architecture patterns, and service mesh is one of the patterns which were there. So the service mesh is sometimes it's used sidecar pattern because it's kind of network of the containers where you will deploy each container to like predefined vehicle, and this vehicle will manage all the. I think I can use it here. So here I have 2 containers I would like to run, and service mesh is adding some extra layer And there is always communication only between the container and this extra layer. And then just these small layers are communicating towards each other. And there are a lot of things I can leverage out of this schema. One thing is that if there is a communication gateway, which is there, I can easily define on this layer who can communicate with each other, with whom. A can communicate with B, B with D, but not A with D. If there is some request coming, then D will throw it away. Okay, this is one thing. Another thing is that I can enforce the encryption between the two components. And the important thing is that this communication doesn't have to be encrypted because it's running in one pod. But outside, it's always encrypted, for example, in this case. And this is enforced and not dependent on what the developer is doing here. Okay. And the third important thing, why it's useful is, let's imagine you have this service mesh, this solution running in the cloud. Each component usually is logging some events, something is happening. Yeah? The problem is where the log files or log records are usually pushed from the component to standard output or error output. And this is going to nowhere because it's running somewhere in the Docker, and it could easily happen, and it's happening all the time, that this instance is killed. Kubernetes and service mesh will create another instance. There is no issue with this. But all the log files are gone. You don't have it. There is no persistence layer you can rely on. And this small component could manage this as well. So this small component could listen to all the standard outputs and error outputs of this of your component, and could send these records to some centralized log repository. We will talk about it a bit later. So there are many advantages of usage of service mesh, and usually, if you have some real-world application, it's usual that you need some communication with some external actors, with your users. Today, it's usually through the internet, and you don't want to expose the services of the components directly to the internet, because then you should solve the security of such component in each component again and again. So usually there is a special component, API gateway, which is working like a gatekeeper for all the requests coming from the internet. Yeah. So here you can check a lot of things like consistency of the requests coming. You can check you can authenticate the calling system or calling user. You can do some throttle limiting, which means that if there are more than specified amount of or count of events, count of requests coming to your application, then the rest are thrown away, because it's usually some kind of misbehave and some expected attack to your solution. Okay, so for the service mesh, there are several options what you can use. Here we have Istio and Linkerd. Of course, there are more options, but those are major ones. Regarding the API gateway, there are even much more options than for the service mesh. Usually the most common are Kong, or you can use, for example, Amazon API gateway. Each cloud provider is offering as a service its own API gateway. At the end, I will provide you the source where you can find all the options for all the components I will mention today. So, any question to service mesh? Okay. Message brokers. If you really are going to develop the microservice-based application, or the application which should be operated in cloud, like, I mean, really efficiently operated in cloud, then you need to separate the synchronous or split the call of the request into several parts. Okay. One option is there is a request coming, and it will be processed here, and synchronously called the service A and called service D. That's okay, and requester will get the answer, usually. Okay. The problem is, if this component is killed in the middle of processing of the service of the request, then the response will not be provided, or the response will be provided like, okay, system or service is unavailable or something like that, or you have to implement quite huge logic here. The more important thing is that in the synchronous processing, you have to work with a lot of resources which are allocated here. Then the resources are allocated here, then here, and after everything is managed, orchestrated, then the resources could be freed. If you will use asynchronous communication, which means you will have here some message broker. Message broker means that I'm sending the event or command to A, and it's written somewhere in the queue, yeah, the message for the A. Once the A will be ready, it will take this message, event or command, doesn't matter, do his part, and then it will provide the response. B will read the response, and then will send another message for the D, and again this will happen. There are many strategies, or there are several strategies how to manage that. It could be orchestration, it could be choreography. Yeah, thank you. But this is not topic for today, so it's really for a topic for the whole lecture in case. But what I'm trying to say that it's really important to use this message broker in your microservice architecture. Otherwise, or if you will use it, your application will be more resilient, will be more effective in cloud. Okay. There are many things, many reasons, good reasons why to use it. So please use asynchronous break and use message brokers. It also allows you to decouple the components from each other. Like you can upgrade just the component A without affecting the component B or the solution itself. Okay. What are the options? Basically, there are three major representatives. RabbitMQ, which is kind of open source flavor of MQ broker, which is message queue broker, otherwise called the smart broker. And then there are two like dumb brokers, Kafka or NUTS. Yeah. Which one to choose? It depends on many factors, on what is the performance I need, which patterns I'm using, I would like to apply, what should be the scalability, fault tolerance, and so on. So the answer is not easy, but yeah, that you have to try all of them at the end to recognize the differences. RabbitMQ is usually like for the services in a more old-fashioned way. If you are really developing microservices using cloud-native principles and 12-factor and so on, then usually you will need more Kafka or NUTS because there is smaller footprint of such solution, and also it's not breaking some encapsulation rules. So basically, Kafka is quite heavy, very mature solution, which is very complex to operate. NUTS is quite a new component, which is very efficient and very easy to use. But not full set of features is available in NUTS comparing to Kafka. So you have your solution somehow up and running, and then you need to, or you should monitor your application. Is it still working? Once something will not work, then probably you will try to get to some logs, some log records. You would like to make a track in the processing of the request coming here. There are again many options which you can use, but usually for the monitoring, the most efficient way is to use Prometheus and Grafana. Prometheus is to deliver the metrics, the data from the pods, to store the data, and Grafana is the viewer of the data. Yeah? It could provide you the information about some infrastructure information, like what is the utilization of CPUs, memory, disk, IOs, and so on. But it could also provide you some business relevant measures, like how many orders do we have? How many rejected orders do we have? How many failed? And so on. So this you can enhance very easily and send this data to Prometheus and visualize them in Grafana. Usually Grafana is provided even to business users, just some limited set of dashboards, of course, but it could look quite nicely. For the logging and tracing, you have again many options. ELK stack. I don't know if you are familiar with this. Elastic Logstash Kibana is one of the options. It's very good for learning, because it's easy to set up, it's free, and that's it. For the real applications, you will then realize that this stack is nice, but very resource consuming. So maybe then you will try to find out some other options which are also possible. And for tracing and distributed tracing, there are tools like Jagger and Zipkin, which are looking to the log files and will provide you the trace of the request coming here. What happened with the request here? What happened with the request here and here? Yeah, on one screen. So you can easily find out why the processing here taken so long, yeah? Or what happened in component D, why there was some error reported. It's also important that the request should have some open telemetry header, yeah. Because based on this information, which could be enhanced and added to the request, then you can trace all the calls, all the processing in your service mesh, and doesn't matter if there is some asynchronous break or not. So monitoring, I don't think that with that you will need this functionality very soon, because it's usually if you try to really operate some solution in the real world, but could happen. But what can be important for you is debugging, yeah. And for the debugging of such solution, microservice-based solution, you have basically two options. Either you have some local environment, everything working on my computer, all the components here, databases, and many things. Okay, there are some tools which you can utilize, like Docker Compose or Minikube or K3s, which are Kubernetes providers, Kubernetes clusters providers, which are not so extensive like the real Kubernetes. You can run it on your computer, you can run it on Raspberry Pi, whatever. And that could be good enough for the start. Once you will realize that you have really a lot of microservices, then you will see that, okay, 32 gigs of memory on my computer is not enough. 64 is not enough as well. So what? I have to buy a really expensive computer, or I have to change the approach. And the approach is the remote debugging. So there are tools you can use where you have the Kubernetes cluster running somewhere on the cloud or server, doesn't matter. Yeah? And then you have your computer here. And you will try to debug some components, let's say it's D. Yeah? So you can configure your computer in a way that you will connect to this Kubernetes cluster, and you can either monitor very closely what's happening here, or you can run the component D here and utilize the service mesh on this point will redirect all the requests to your computer. Yeah, and here you have in debugger just one component, and you can debug it. You can even utilize any resource, any database which is running here. So you don't have to run the database here, and it's much better for the bigger solutions. It's even much safer, because usually if you have a really huge solution at the end, like 50 microservices, 50 components, then it's not done by one person or one company. It could be delivered by many companies, and no one knows, no one wants to his components are running somewhere on the development machine of the other company. So it's also the security issue. If you have remote debugging, then the environment is stable, and I'm solving just one component on my machine. And there are several options: kubectl, port forwarding on the level of Kubernetes, or you can use telepresence or squash as a providers, components which are running. Some agent is running on your computer, some agent is running here, and it's much easier for you as a developer to set up the debugging. Okay. For sure, you already heard about the CI/CD, continuous integration, continuous deployment. Why it is so important in the world of microservices? Because if I have the microservice architecture, then each microservice is developed typically by some other person, by some other programmer. And they would like to introduce a new feature of their component, and thanks to service mesh and other components, they can do it. So they can build a new version of the component and deploy it directly to specific environment, to try it, to provide it to the others as well. And for this, the CI/CD is a good way, and there are a lot of other advantages of this approach, because and the best one from my point of view is that once you automate the process from the source codes you develop to deployment, then it's very easy to see that you cannot hide anything. You have to provide all the dependencies, all the sources, all the libraries, how to build them together to one image, how to configure them, because if they are automated, they will not be there. It will not work otherwise. And this is very important aspect that the developer cannot, doesn't matter if intentionally or just by accident, cannot hide or abandon to provide some information to the solution, and everything is in place. This is very important. For example, if you have a company utilizing some vendor to develop part of the application, then it's very good to know that, okay, for the production environment, we are running this version of the component, this configuration is needed, this kind of libraries and so on. Because then if you are not satisfied with the vendor, you can easily switch it, or easily. You can, it's at least possible to think about change of the vendor. If you don't have this information, okay, maybe you know maybe you own the source codes, but if you don't know how to build the solution, how to configure it, it's more or less useless. So there are a lot of tools today for the CI/CD. Usually it's working in a way that you develop something here, push the source codes to some source code repository, which is commonly some kind of GitLab, GitHub, Bitbucket, whatever you are using. And then all these tools are taking the source codes from the repository and starting to build your solution, to build the Docker images, and then to deploy the Docker images to Kubernetes cluster or clusters, depends on the configuration. And together with the Docker containers, the images, also the configurations are very, very important. So You can use tools like Jenkins, Tekton, Argo CD, or GitLab CI/CD solution, GitHub Actions, Azure DevOps. There are really plenty of them. What is important to really know that all those tools will manage the build and deploy, but will not manage the operation. So you have to operate it afterwards on your own, okay? Which means that the CI/CD is a very important part of the solution, but to run the solution, you need the observability stack in place as well. And for example, we have some not nice experience at our client. Usually, he was using Azure DevOps. It was working very nice. And then they realized they need observability to make it keep it working, the solution. So they switched on the observability stack, which is also available, provided by the Azure. But the Azure DevOps is for free, but the observability stack is not. And this company, it's quite known e-commerce company in Czech Republic. I will not name it. Switched on the observability stack on their solution. And they really paid $10,000 per 2 hours because of this observability stack. Afterwards, they switch it off instantly because it didn't make any sense for them. Yeah? So be careful if you will choose the CI/CD tool. Sometimes, or you have to think upfront. You have to think forward how or which observability stack you will use for your solution. Otherwise, it could be pretty expensive. Okay, and one thing I would like to mention is what are the deployment strategies for microservices. Okay, and there are basically three major options you have. One thing is the rolling update, which means that okay, I have new version of the component D, so the service mesh or Kubernetes itself will deploy a new version. Let's say this is version 1.1. This will be version 1.2. Yeah, it will deploy a new container with a new version. Okay, once the container is deployed and it's up and running, the traffic is redirected to the new version, and this old version is undeployed. Okay, so the pod is deleted. This is called rolling update, which means that if you have any issue with the deployment, with the stability of the component, then this redirect will never happen, and your application will still work. Okay, it could be even further that, for example, Istio could manage for you that if this new version will repeatedly fail during first 2-4 hours of the operation, then it will roll back automatically to the previous version. This is the rolling update. Other option is to create a new, really new environment, which will contain, so there will be one environment, the new one, and the old one. Yeah, this is called blue-green environments. And they are both available at the same time. And there is kind of load balancer, which is managing the traffic coming to the component D. And you can increase the ratio of the requests processed by the new version in any way you like. So you can manage on this layer how many requests will be managed here and how many requests will be managed here. You can even do some more like business logic here, that for some users, based on IP address, based on user, whatever, you can decide whether the user will have new features available or just the old ones. Yeah. And this is blue-green deployment, and the load balancing here is called like canary releases, that you will release the new functionalities in a sequential way, not all the traffic from one to the second, but you will enlarge the number of users using the new version of your application. And you can this is particularly useful if you are doing some performance optimization or introducing some features which could have like potential performance impacts. Then you can easily switch like 10% of your traffic here, and you can observe in the monitoring on Grafana if the utilization of the resources by this new component is reasonable, or if it's too high, and you have to come back and do some refactoring of your code. Okay, and the last thing, or one of the last things you need to know, is the configuration management. We already talked about the number of services and number of environments you have to manage. I have mentioned that you have, or you should have, at least 3 environments for the production solution. Usually you don't have 3, you have 5 or even more, yeah? Because you can have on top of those 3 the development, testing, and production. You have usually some integration environment for the developers, and you have some it's called pre-prod or bug fix environment, where you have the identical environment to your production, with even sometimes production data with the same configuration. And if you have any issue on the production, you have some fix in your code, and this bug fix environment or pre-prod environment is really the one where you should try the new version, or you have a new update or new version of your library, or whatever component, even maybe not developed by you. Then these kind of updates you can try on the bug fix environment. So maybe you have 5 environments, 30 components. It's 150 components and configurations to be managed. It's quite clear that you have to separate the configuration from the code. With a monolithic application, you can somehow handle 5 different configurations using some defines, some ifs, and whatever constructs are allowed by your programming language. But if you have 150 of them, that's definitely a nonsense. So the configuration cannot be part of your code. This is one thing. This you can have, and usually you have different configurations for different environments, and this will enable also the automation of your deployments. If you have configurations predefined for the component and the environment, then it's easy to automate it. And by the way, and we will talk about it a bit later, these configurations are usually also stored in the source code repository. It's not the same information, but still this kind of component, the source code repository, is very useful to track the changes. And the last thing why it's good to have it separated from the code, that you can separate the code from the sensitive kind of data. So you don't have to, or you should not store kind of connection strings, usernames, don't mention the password in your source codes. Yeah, so it's better to store them to configuration files, with one exception of the passwords. I would not recommend even passwords to store there, but this is the part of the configuration management strategy. Okay. So usually it's kind of mix. You are not using one very clean approach in your solution. You have to mix those strategies. First strategy is that you will push the specific configuration to your component through the environment variable, yeah? Which means that you have some configuration file for the component D for the environment prod, for example, and the component responsible for the deployment, Jenkins, Argo CD, whatever, will deploy the component, like the binary file, but will also deploy the configuration file there, and will manage that the content of this configuration file is stored in the environment variables of the operating system. Then it's very easy and language independent. You can read those variables in your code, and you can get the information about the connection strings, usernames, passwords, and so on. And it could be filled there during the runtime. So the programmer doesn't need to know all this information. Only the component will know it. Of course, you should not lock these values to the log repository. So this is one approach. Another approach is the configuration files. As I said, the configuration file for the component D and the environment prod stored in the source code repository. Good way how to do it, or in some real, like, huge enterprises, you can have some configuration store, which is somewhere aside of any applications they are running, and they have configuration stores for or the information storing for all the applications they are operating. But this is really for the huge enterprises. And also, not very popular aspect, the security of the microservices. So, what's the problem with the security in a Kubernetes cluster? What do you think? You have your components running here, but maybe there will be other components running in the same cluster. Maybe they will try to call your services. And the question is, what to do with this? So the first approach is to secure each microservice with the authentication, authorization, and so on. So once the request is coming here, and this is one of the advantages of service mesh, that this subcomponent could check the identity of the client, could check if this client could call the service A or not, and so on. There are many options how to manage that. Usually there are two components important for that. Identity access management component, which is providing the information about identities of the components. It could be technical users, it could be even the users using your application from here. This is one thing. And then there is a policy agent, which is a declarative way how to specify who can do what in this service mesh. Okay? The advantage is that it's declarative, which means it's usually quite simple to define, and you don't have to manage all the ifs and then. No, you just have to define, okay, for service A, the identity of technical user of service B can call it. That's it. And I don't have to, it's also replacing and helping with the network security, because in usual way, you have one instance of A and one instance of B, and in virtual machines there is a security team or network team which have a rule defined. A can communicate to B. That's it. But what if I have 100 of instances of A and 50 of instances of B, and their IP addresses are changing all the time? Then I cannot rely anymore on this security layer provided by the network layer. So I can utilize the service mesh as a security layer as well. And if I will make it working together with the policy agent, then it's very easy to define who can communicate with whom. IAM will ensure that the A know who the other party is, and that's the way how to proceed in this. By the way, this pattern that each call is validated on this layer is called zero trust architecture. And I don't know if you have heard this term before. It's one of the new standards defined by the US government, for example. So if any company would like to deliver a new application, new solution to any US government, it should be coherent with this zero trust architecture. That's because if you would like to operate your solution in the cloud, you cannot rely on anything else. What are the other options we have, or what we can use? What I was talking about was the operation of the solution, but we can check even before if the solution is okay or not, or some aspects we can check. And there is a static analysis of the code, some components. You can use SonarQube, you can use Claire, Prisma Cloud for the static or real-time analysis of your solution, which means that it will analyze your code if your coding standards are somehow aligned with what is expected. If there is not any recognized pattern for vulnerable code, if you are not using some kind of library which is already known as vulnerable, and the same during the runtime. You can develop something, have it running for 2 years, most probably, or for sure, the static analysis was fine at the time you developed the component, but afterwards the vulnerabilities could be recognized, could be discovered in specific libraries you have used. So for that, Prisma Cloud could be useful, which will scan continuously your Kubernetes cluster and provide you some insight of the level of security or potential vulnerabilities of your solution. All those tools are usually available in open source versions, but they have also some enterprise versions, paid, even quite expensive. Of course, you will get more insights, better analyses, whatever, with the higher versions, but I think for the start, it's the open source is good enough, and it's definitely better than not using any tool at all. And the last thing I would like to mention is the secrets management. I already mentioned that it's good to store some configurations for the components and environments in the source code repository, but I also mentioned that it's not a good idea to put there the passwords or other sensitive informations like tokens, private keys, and so on. So for this purpose, there are several options where you can safely store this kind of sensitive information. It could be Kubernetes secrets, it could be HashiCorp Vault, it could be service provided by the cloud providers like AWS Secrets Management, Azure Key Vault, and so on. In the really if you really want to use very secure way, then there is a possibility to use HSM machines, which are in fact cryptographic devices. You can use them on-prem, you can use them also in the cloud. It's possible. Cloud providers are offering this as a service. Okay, and most unpopular thing in development is testing. No one likes to do it, but with microservices, there is no other way. Otherwise, you will not get your solution working. If you have really distributed functionalities and there is one issue somewhere, then it's very hard to recognize where the issue is, or which component is causing the issue. So you have to test at least each component itself. Yeah? There is also very known anti-pattern for microservices adoption. First, you should adopt automated tests of your source codes. So part of your development or coding experience should be that you will not only code the business logic for your application, but you should also code the test units for that. And you should not go to microservices before you manage that. Otherwise, you will not write the unit tests, and without that, it will be very, very hard to make the solution working. What is very important is, or quite used strategy, is the contract testing, which means that okay, I'm not testing only this one, but these messages are defined based on some, or could be defined based on some contracts. And I can test if the component B is fulfilling the contract, and I can test, so if there is something coming, then the specific message will go out. The same on the component A. something is going in, then there is a specific structure expected to be provided on the output. And this could be tested. This is called contract testing. There are a lot of tools available. I will not go through all of them. They are really specific to be used differently by different languages usually. And also it depends. If you will work for any company, like professionals, then such company usually, or they should have such tools already adopted. If not, then at least keep in mind something like that should be there, and you should ask. If you will ask about this on the job interview, I think it will be a huge plus for you. Because, okay, you are junior, but at least you are aware that something like that should be done. And at the end, the perfect state is that all these tests are automated within your CI/CD pipelines, which could mean that, okay, there is a build phase of your components, and then after build is done, the specific set of tests are run, and the solution is not deployed until some quality gate is achieved. And it could be also differentiated, okay, for the test environment, the quality gate could be this. For the production environment, the quality gate could be much higher. Okay, so I will not be able to deploy something which definitely cannot work on the production environment. This is the last slide. It's just a screenshot. It's publicly available, very good source of all the tools you can use. It's called Cloud Native Landscape. It's provided by the Cloud Native Computing Foundation, and you will find there a lot of tools for different areas. You can look at the specific area. You will see which tools are really mature, which are quite new, so how much you can rely on them. As you can see, there are really plenty of the tools. I have only mentioned some of them. From my perspective, I wanted to introduce to you different categories of the tools rather than the tools itself. You can find the tools here, and even the situation is really volatile, and what I said today is maybe valid today, but within a year it could be completely different situation. New tools are emerging. The companies are buying some tools from the mentioned here. Sometimes it happens that afterwards the development life cycle is stopped. It's very hard to say. So that's why it's good to have this. This is really like living landscape. It's updated regularly, so you can have a look on this site, and you can always find some most updated and relevant information. Any questions? If not, then thank you for participation. Yeah?
Maybe I have the one. You mentioned that you have, for example, sorted microservices.
Yeah.
In the beginning, you have the monolith.
Yeah.
So is there any strategy how to start? Okay, let's start with 50 or...
Yeah, that's a very good question. In fact, we are solving exactly this situation on one of our projects, and I didn't mention that. It was not part of the tools, but it's not a good strategy to start like a microservice first. The good strategy is to start with a structured monolith. Yeah? So you should start to develop, because at the beginning you have just a few libraries, few classes implemented, so it doesn't make sense to already distribute all of them to microservices. It's better if you start with one monolithic solution, monolithic from the deployment perspective. Yeah? But it should be already somehow structured inside, yeah? And maybe, and this is really the case, even the experienced architects and developers are facing that at the beginning they think about some kind of structure, and after, I don't know, 2-3 months of development of such solution, they will realize that, okay, this was not good idea. It looked good, but it's not good. And this we have to split or structure even more than we thought before. Yeah? If you have already this, the separation to microservices, then you have a lot of refactoring to be done. If you start with this, once the component is really like identified, yet yes, this is the right granularity of the component, then you can separate it from the rest. And well, you have first microservice in your solution. As the time goes, you will identify another one. So you will also isolate it. And those two already could be deployed independently on the rest. And in this way, you can end up with some really like good design and a good solution based on microservices. So please don't go with the microservices from the beginning to have like 15 of them at the beginning. It's not a good idea. It's a good idea to have a structure. That's definitely a good idea, but you don't have to deploy them independently.
And what about the communication inside this first monolith?
Mm-hmm.
Do you use synchronous or asynchronous?
It depends when the in the situations where it's very clear that the asynchronous communication will be there, needed, then do it from the beginning. It could be one monolith, and you can still utilize your queue. So this component will write something, and this one will read. It's completely fine. Yeah. Of course, it's also somehow emerging, and it depends on how your design approach is. If you are going with event-driven design, then you will have the asynchronous communication from the very beginning between maybe all of the parts of your solution. That's my preferred way of working, but it depends also on the experience and programming language and subject area, if it's which kind of business it is, and so on. Non-functional requirements and a lot of things to be considered.
Does this use the sidecars and this Istio service mesh in the beginning, or
Not necessarily. It depends on your stack, what you are using. If you are using some kind of automation platform, then yes, why not to use it from the beginning? If you don't have it, okay, this is manageable. If you have to deploy it at once, then you can do it quite easily, even on your computer. It's the important thing is that the world is not black and white. There is nothing like perfect architecture. It's just some abstract thing. I have heard one good comment on this. Architecture has to be like evaluated always within the context. So this architecture could be perfect in one situation, in one context, but could be complete disaster in other. So just think about it. Yeah? Mm-hmm. Mm-hmm. Nothing will happen. You are processing your request. Of course, there could be an issue if you are communicating synchronously. If this is a synchronous service you are providing to the other components, then of course it could happen that you will hit some timeout. Yeah, but if you are using the asynchronous communication, then it's completely fine. You will get a message, and you will process that, and after all, you will put another message or more messages to the queue at the end. Yeah, and everything will go fine. Yeah. Of course, for this kind of configurations, for this kind of integration environments usually, or development environments, the configurations are adjusted, so the timeouts are much longer than usual.
Any other questions?
No? Okay. So thank you for your attention, and I hope that you will use something in your work.